Hi everybody. In today's video, I cover a very basic but very important topic of present value of money. So though this video is a part of the series on IFRS 16 leases, this is a topic that is used in multiple topics across accounting and finance. So I'm sure that I will be referring to this video in many of my upcoming videos. Right? So let's get started. What I will cover in this video is what is present value of money, why do we need present value of money, and finally, how to calculate the present value of money. Let's start with what is present value of money. Let's look at an example. So this is 15-year-old Pete. In 2019, he has $100. He has seen a pair of shoes that he wants to buy that costs $100. But he wants to wait for 3 years until he is 18 years old. He takes that $100, puts it in his wallet, and waits until it becomes 2022. But in 2022, he is shocked to see that the price of the shoes is $116. So he can't afford that shoes anymore. When he speaks to the shopkeeper tells him that this increase in price is because of an inflation of around 16% over the 3 years. So now what we see over here is that although $116 is greater than $100 in absolute terms, there has not been any real change in the quality of the shoes, of the underlying asset. So the underlying value of both $116 in 2022 is the same as $100 in 2019. The present value of 116 is 100 in 2019. What has changed? Nothing has changed except the passage of time. So this concept is known as the time value of money. Let's take another example. It's Pete's dad this time. He also has $100 in 2019. He invests it very intelligently in the stock market, and in 2022, his portfolio stands at $120. So he has got a 20% return on his $100. Right? So the time value of money is at play here, and we say that the present value of $120 in 2022 is 100 in 2019. Now, with these examples in mind, it becomes very easy for you to understand the definition of present value. Present value is the current value of a future sum of money or a future stream of cash flows given a specific rate of return. Why do we really need to go into this trouble of calculating the present value of money? Now, Pete's dad, he has $100 in 2019. Instead of taking the risk of investing in the stock market, and he's looking for alternative avenues to invest his money. A friend of his comes and tells him that if he invests in a specific business, he will receive $110 in 2022. Should he invest or not? In absolute terms, 110 is way better than 100. And a 10% return is much better than what he would have received if he put his money in the bank. If we just went by the absolute amounts here, he would have gone ahead and invested in the business. But we want to know what is the value of that money in 2019 when Mr. Pete is taking the decision to invest. We calculate the present value of 110 at a rate of 16%, which is the inflation, is $95 in 2019. Therefore, what you're doing is not gaining money, but losing money. And your investment decision then becomes, do not touch this investment. So you see, it is very important to calculate the present value of money so that you make wise investment decisions. It is also important for a company to present information about future cash flows using the present value of money so that a user of financial statements would make intelligent decisions based on that. Now we go into the more practical aspect of how to calculate present value. So let me jog your memories a little. I take you back to your school days when you had learned this particular formula. calculation of the amount that we will receive if we invest a specific amount of money at a particular rate of return for n number of years. So let us assume Mr. X has $100 and he invests it in a bank for 4 years at the rate of 5% every year. In that case, this is what our formula would look like. You have $100 multiplied by 1 plus the rate of return raised to the power of the number of years. This calculation comes out to 122. Now, if you observe this closely, you will realize that 122 is the future value of 100. So 100 is the present value of 122. So what we are interested in, unlike in our school days, we are not interested in A, but we are interested in P. So we are interested in knowing what is that amount in the current period that will ultimately result in a cash flow of 122 4 years hence. So we just turn this formula around a little. P is equal to the future value divided by 1 plus R by 100 to the power of n. Right? So if we use the same method, the present value is equal to 122 divided by 1.05 raised to 4. Over here, the 1 divided by 1.05 raised to 4 is known as the discounting factor. And this is what we will be using in our calculations of the present value. Okay, we start with the first problem. The current date is 1st January 2022. Right? Over here, you see the date at which we receive cash flows. So we receive it at the end of every year for 5 years. Right? I will come back to this column later. These are the cash flows that are coming in. Now, we want to find out the present value of the total cash flows that are coming in. In this column, that is year in numbers, we are going to write down how many years is it after our current date when this cash flow will come to us. So we know that it comes in 31st December 22, which means it is exactly 1 year after the current date. So I put in 1 here. Same way, here we come to the discounting factor. If we look at this, the 30,000 is the A we refer to in the formula, right? We need to discount it. So the formula over here will be 1 divided by the discounting rate is 5%. So 1 plus 5%, which is 1.05 to the power of whatever is the year. So this is the discounting factor. If I do the same thing here, but now it is no longer raised to the power of 1, it is raised to the power of 2. Correct? Because it is Excel, it is super easy for me. I just need to copy it. There. So I've got all my discounting factors. And then what do? I multiply the discounting factor with the cash flow. So what does this mean? Getting 50,000 at the end of year 5 has the same value as 39,176 today. So what is the total present value of the money that I will receive from this project? It is 1,54,230. Let us say you are writing an exam and you do not have MS Excel with you. You have just a calculator. In that case also, it is possible to calculate the discounting factor. Now, if I want to find out the discounting factor at 5%, what I do is 1 divided by 1.05. 0.952381. It would be good to put in as many decimal points as you can to get the answer really close. Now I want to find out that raised to the power of 2. All I need to do is press equal to again, and I get the next discounting factor. So that I put in 0.907029. Right. Again, I press equal to, and so on. Right. So as you can see, the answer is the same. So this is how you calculate the discounting factors using your calculator. Let's say instead of getting different cash flows in different years, we get the same cash flow. So we get 30,000 every year for 5 years. In this case, if you have Excel, once again, it becomes really easy for you to calculate the total amount, and you get 1,29,884. What if you don't have Excel? Is there an easier way out? There is. This method can only be used if you have a uniform cash flow for multiple years. This is known as an annuity. So, like I show over here, for years 1 to 5, you are receiving a cash flow of 30,000 every year. How do we calculate the annuity factor? So once again, I open my calculator, the same formula, 1 divided by 1.05. But now there's an additional step, and that additional step is I add this to the memory. So I add it to the memory, and then calculate once more, add it to the memory, discounting factor for the 3rd year, add it to the memory, discounting factor for the 4th year, add it to the memory, discounting factor for the 5th year, add it to memory. And then I press memory recall. This is my annuity factor. So it is 4.32947. 4.32947. I get the exact same present value as I did when I calculated it individually. So this is particularly useful if you have uniform cash flows coming in for 10 years or 20 years. You do not need to calculate the present value for each year. You can apply this annuity method. Now we come to the last variation of this problem. Let us say that instead of receiving the cash flows at the end of every year, you receive the cash flows at the beginning of the year. So as you can see, the first cash flow has come on the current date itself, on 1st Jan 22. The next cash flow comes at the beginning of 23, beginning of 24, and so on. In this case, the year in numbers changes, right? So over here, if you see 1st Jan 22, 0 years have passed since this, so it will be 0. Over here, it will then be 1 now. So the beginning of the next year is 1 year since the current date. The final present value is 1,61,924, whereas the earlier one was around 155,000. So this is a very important difference to note. As always, thanks very much for watching this video. This concept of present value of money we will be using in my upcoming videos on solving lease accounting problems. Please share in your comments for improvement, and I hope you find this video very useful. Thank you very much. Bye.